Hey guys, so someone just requested that for the unit circle. So here's what I want to talk about today regarding the unit circle. A lot of students having trouble with the unit circle because they thought, all those ratios coming out from nowhere. But if guys you recognize that special right triangle, we do have two special right triangle. One is 30, 60, 90, and the other one is 45, 45, 90 degree. So basically we can use the ratio of those two special right triangle to set up the xy coordinate and also the directions with the radian and degree. But now let's start with the first quadrant. And many of you guys already know that the quadrants, so the first quadrant is always considered positive, positive. And then the second quadrant, it's negative, positive. And then the third quadrant is always negative, negative. And then quadrant 4, it's positive and negative. So if that's a unit circle, so that means the radius is always 1. So radius is always 1. And then the endpoint right here, it's always considered 1 comma 0. It's just like the x-intercept. Okay, again, radius is 1 unit, and then the y value, that's nothing, it's just 0, so it's 1 comma 0. And then the radian, we always started with the horizon, so 0 degree or 0 radian. And then the next position here, so we do have 30 degree, so just make an R here, so that's 30. So this one is like 30, 60, 90 degree triangle. So if that's 30, 60 degree, 30, 60, 90 degree triangle, so the ratio, it's always considered 1, root 3, and 2. So by using that SOHCAHTOA, we do know that cosine of 30, it's adjacent over hypotenuse. So that means this one is considered root 3 over 2. And then for the opposite, the ratio here is 1. So sine of 30, it's opposite over hypotenuse. So it's 1 over 2. And then for the next position, guess what? We do have a 45 degree for the angle. So that one is considered 45, 45, and 90. So for the ratio of 45, 45, 90, which is considered 1, 1, and root 2. So again, cosine of 45, so it's adjacent over hypotenuse, so it's 1 over root 2. And for those you might be wondering, can I rationalize it? Yes, you can. So that turns out to be root 2 over 2. Okay, let me just fix that. So that one there, it's considered root 2 over 2. And we do know that 45, 45, 90 degree, it's an isosceles triangle, so that means the ratios of cosine of theta is the same as sine of theta. So that means sine of 45, it's also considered root 2 over 2. Again, this one is 45 degree. If you just convert that to radian, which is considered pi over 4. And then for the next position, we do have 60 degree. So this one is just going back to like 60, 30, 90 degree, but the angle obviously is getting bigger. So cosine of 60, so we do have 1/2. Again, it's adjacent over hypotenuse. And then for sine of 60, we do have root 3 over 2. So this one for 60 degree, convert that to radian, we multiply by pi over 180. So we do have pi over 3. And back to the radian, for 30 degree, we do have pi over 6. And guess what, the position's up here, so it would just make a turn perpendicular. So this one is 90 degrees, so which is pi over 2. And for this position, since that's the max, again, the radius is always 1, so that means the position here is 0, comma 1. And for those you might be wondering, how do you figure out the rest of those quadrants, the ratios, the xy coordinates, and also the position for the angle? And this one is all about the reflections with the x-axis and the y-axis. It's all about the line of symmetry with those two axes. So for this one here, it's just reflecting involving with the y-axis. So over the y-axis, so this one's pi over 3, so that means this one here got to be 2 pi over 3. And also the ratio would be pretty much the exact same thing. The only thing that's different is the sign change. So instead of being 1/2 root 3 over 2, so this one turns out to be negative 1/2 root 3 over 2. Same thing happened with the rest of this. It's all about the reflections. So this one is 2 pi over 3. And then the ratio, we got negative 1/2. And then positive root 3 over 2. And then for the next position, so this one is reflected with that 45 degree, pi over 4. So that means this one would be written as 3 pi over 4. And then for the ratio, we just need to change the sign. It's reflected over the y-axis. So it's going to be negative x and comma y. So we got negative root 2. And then positive root 2 over 2. And then for theta down here, so this one originally, that's pi over 6. Then this one turns out to be 5 pi over 6. And also the ratio is almost identical, but this one is negative positive, so it's negative root 3 over 2. And then 1/2. And then back to the horizon on the left hand side, so theta, this one turns out to be pi because that we're making the straight angle, which is 180 degree. And then the position here, it's going to be negative 1, comma 0. And then for those who might be wondering for the rest of the quadrants, so this one is all about the reflections over the x-axis. Okay? So we try to complete the rest of the blank here. So here's what we found for the final unit circle. Okay, so for quadrant 3, so we got 210 degree, which is 7 pi over 6. It's negative root 3 over 2, negative 1/2. And then 225, which is 5 pi over 4, negative root 2 over 2, negative root 2 over 2. Again, it's all about the reflections over the x-axis. And then down here, 240 degree, which is 4 pi over 3, negative 1/2, negative root 3 over 2. All the way down to the bottom, the minimum, 270, so it's 3 pi over 2, 0, comma, negative 1. And then quadrant 3, so the rest of the number. And then the angle, we just need to add 60 degrees, so we do have 300 degree. 1/2, negative root 3 over 2. And then at 15, so we got 315, 7 pi over 4, root 2 over 2, negative root 2 over 2. And then 330, 11 pi over 6. So the ratio, again, it's all symmetrical. So root 3 over 2, and then negative 1/2. And then back to the original position, 360 degree. So back to the horizon.